Hello students, welcome to my channel PhysicswithSMsir. If you are new to this channel, please subscribe to the channel. And if you like the content of the video, please do not forget to press the like button. This gives me more motivation so that I can bring more videos for you on different topics. So today I am going to start to discuss about a very important topic called refraction of light through prism. So let's start. Now the question is, what is a prism? What is a prism? Prism is actually made up of some transparent material. Okay, it may be glass or maybe some kind of stone which is transparent. Correct? How the prism looks like? Let me draw the diagram first. Look at the diagram of the prism. Actually, this is a two-dimensional view of the prism. Now look at this. This is what we called base of the prism. Okay. And these are all called, these two are called, both of these, 1 and 2 are called, 1 and 2 are called refracting surface of the prism. And this is what we called edge of the prism. And this angle is a very important angle called angle of prism also called prism angle or angle of mitra of the angle of the prism. Okay. Now look at this clearly. If we cut the prism perpendicular to its base, we'll get a view like this. If you cut the prism perpendicular to its base, we will get a view like this. Correct? Now this is what we call principal section of the prism. Correct? I will teach the entire chapter by taking this diagram in consideration. Okay, this is called angle of prism and this ABC is called principal section. Correct? And these are the two surfaces, 1 and 2, and this were called base. Now in this case, first I'm going to show you what will happen if a light enters through a prism. Correct? Now look at this. Let me draw the principal section of the prism again. And how actually refraction takes place through the prism. Now, watch this very carefully. This is suppose A, this is suppose B, and this is suppose C, where A is called the angle of the prism. Now, say for example, a ray of light is entering the prism like this. So if you follow my video, you will find that I had told you many times that at the time of drawing any kind of ray diagram, please always draw a normal, because this will help you to mark the angle of incidence, angle of refraction. And never forget to put arrowhead on the ray diagram. Correct? And this is what we call angle of incidence I1. Now, if I assume The refractive index of the material of the prism is supposed to be mu, and it is made up of glass, for example, and outside is air. Say, for example, outside is air. So obviously, glass is optically denser with respect to air. So when a ray of light enters the prism, it will move towards the normal. Correct? I'm not saying it is always move parallel to the base. Correct? I am in this case saying it will move towards the normal. Clear? Now what will happen? Let me write down this as angle of refraction. This is the angle of refraction in the first surface. Correct? Now what will happen? Draw again a normal on this face. Let me draw a clear normal first. Okay. Now what will happen when this ray of light passes through the prism and comes out of it? That means when it passes from glass to air, since air is rarer compared to glass, the ray of light will bend away from the normal. So if you watch this diagram carefully, you will find that in this kind, means the if outside medium of the prism is rarer with respect to the material of the prism, then the emergent ray, which is this one, always moves towards the base of the prism. Correct? Now this is R2, which is called the angle of incidence in the second surface, and this angle is called angle of emergence. Right? Now this is the ray diagram for a prism in normal case. Now I'm going to show you how to calculate the angle of deviation. So what is angle of deviation? What is angle of deviation? What is angle of deviation? In case of prism? It is the angle between the incident and the emergent ray. Incident and the emergent ray. Correct? That means what we have to find out in this case, how much bending takes place while a ray of light passes through a prism. So what I'm doing here, I'm extending this normal, correct? But what I'm doing here, in order to show the extension, instead of using same red color, I'm using black color, so that it means that is not the ray, actual ray, that is the extension of the ray, correct? Similarly, I'm doing this for the emergent ray also, correct? Look at this. Now, in this case, look, this is the path of the incident ray, actual path, means initial path, that the path along which incident ray was initially moving, and this is the path along which emergent ray moves. So in this case, deviation occurs along this direction. That means what direction? It is in clockwise direction, correct? Now our task is to find out what is the value of this angle of incidence. So let me do one thing, okay? Let me write it like this: P, Q, R, S, and this is the normal N, okay? Now, if you watch this carefully about the angles, correct? Watch it carefully. In the triangle, means what we can write here, if I write this as, say, for example, PQRS, suppose this is T, this is U. Please follow this geometry carefully. Yeah? Angle PQP is equal to angle. Look at this. Which one is vertically opposite to this? This angle is vertically opposite to this. That is, N, Q, and say for example, this is M. That is N, Q, M. These two angles are vertically opposite. So what will be the value of this? I. Now, watch this. If NQN is I, so what is the value of the angle NQR? Correct? That is equal to what? I1 minus R1. Clear? Is that clear to you? Okay, let me explain it more in a more way. Okay, note it down. It's better. MQR can be written like this. MQR is actually angle MQN, okay, minus of angle RQN. It is clearly seen from the diagram, correct? MQN is nothing but this I1 and this R1. Similarly, if I want to find out the angle in the similar way, if I do the calculation for the other side of this, that means if I calculate MRQ, I will find the same way this I2 minus R. Now, what we know in the triangle MQR, from this triangle, what we can write? We know that extrude angle is equal to sum of the opposite interior angle. So delta in this case represent extrude angle. Its sign is delta, correct? Okay, delta. Okay, delta is equal to what? Extrude angle is equal to sum of the opposite interior angle. That means sum of MQR plus MRQ. If we put those values in this equation, so we will find this I1 minus R1 plus I2 minus R2. If I do this calculation, I will get I1 plus I2 minus R1 plus I2. Okay? Delta. Now, let's come to another question. Okay? Now, let me erase this question. Okay, now watch it. Now, if we look at this quadrilateral AQNR, the quadrilateral AQNR, and what we know, sum of the four angles of a quadrilateral is equal to 180. Now, TN is nothing but a normal drawn on the line AB. So this angle is actually 90. Similarly, this UN is nothing but a normal drawn on AC. So this angle is also 90. So if I take this quadrilateral AQNR, what we can write, angle A plus 90 plus angle N plus 90 is equal to 360 degree. That means A plus N is equal to 180. Okay. So now look at this very carefully. So what we can write, N is equal to 180 minus A. Okay, let's mark this equation as 1, this equation as 2, and now let me consider another triangle. That is a triangle A, triangle N, triangle N, Q, R. Okay. If I consider this triangle now, then what will happen? Look at this. Sum of the three angles of a triangle is 180 degree. So we can easily write this as R1 plus N plus R2 is equal to 180. Now R1 plus R2, substituting the value of N in this equation from this relation, if I put that 180 minus A equal to 180, so 180, 180 get cancelled, and A equal to R1 plus R2. That means prism angle is equal to sum of R1 and R2, and delta is equal to this. Now, if I put out the value of the R1 plus R2 in this equation, I will get the relation delta is equal to I1 plus I2 minus A. So this is the technique of solving. This is the technique of calculating the value of deviation when light ray passes through a prism. Is that clear to you? Okay. So this is a very, very important one. Correct? Please pause the video and check the calculation again. And then I'm going to tell you something very important related to this. Now, what is that? Look. The thing is that I'm going to plot very, very important curve called I delta curve. Correct? What do you mean by I delta curve? That means what will be the value of deviation produced by a thin prism, produced by a prism, when angle of incidence are different. Clear? So for that, what we have to use this relation again, delta equal to I1 plus I2 minus A. Now, you have to follow something very, very special, correct? From this particular calculation or formula, what we can write, please note the point, angle of deviation produced by a prism depends upon angle of incidence. Okay? Incidence. Okay. This is number one factor on which it depends. Number two, it depends upon the angle of prism. Okay. And number three, it depends upon material of prism. Now, you may have a question like this, why I'm not writing I2? Because I2 solely depends on the material of the prism. Clear? Clear? I2 solely depends on material of the prism. That is why instead of writing I2, I'm writing material of the prism. So these are the three factors on which angle of deviation produced by a prism depends. Now, for a given prism, okay. For a given prism, it is quite clear if the prism is given to you, that means it is a complete prism. That means A is constant. A is constant, correct? Now what we do here, we will take different angle of incidence. That means the light ray will fall on the side of the prism at different angles, correct? For example, let me draw a diagram again. So this is the normal drawn. Now say for example, sometimes light is falling like this. Sometimes light is falling like this. Sometimes light is falling like this. Okay, these are the different incident rate. Okay, these are the different incident rate. Clear? Now, for each of these, it means actually I am not going to consider only 3 days. We'll consider many days, correct? But what will happen? I'm going to show you what will happen in angle of deviation, correct? For that, if you do this experiment in laboratory, you will find a beautiful curve called I delta curve. Okay, where I stands for angle of incidence and delta stands for angle of deviation. Okay, now watch this curve very carefully. When the angle of prism means I am plotting delta along y-axis and I along x-axis. When I am plotting I delta curve, correct? When I am plotting I delta curve, okay, you will find that when the angle of incidence starts from 30 degree onward, the pattern of the graph looks like this. Okay, from 30 degree onwards. Before 30 degree, correct? There, because of some means you will not get the so much regular curve, correct? So if I start the angle of incidence from 30 degree onwards, I will get a curve like this. This is what we call I delta curve. Now, look, this is the important significance of this curve. Okay, what are the significance? Watch this carefully. Look, if I draw a line parallel to this curve, correct, which is touching the bottommost point of the curve, that means this is the point at which delta is minimum. So this actually happens for a particular angle of incidence, correct? This actually happens for a particular angle of incidence. Look, very, very important part is this. This particular thing occurs for a particular value of angle of incidence. That is I. This I is a special angle for which delta is showing minimum deviation. If you watch this curve carefully, before I, delta increases, after I, delta even increases, correct? So this is the position at which deviation is minimum. So this is the angle for which deviation produced by the prism is minimum. Now let me show you another interesting fact related with this. Ignore delta. Take any other value, correct? So let me take any arbitrary value, for example, this. For example, this. So if I draw a line parallel to I-axis, look, this is a certain value of delta, obviously not delta minimum. And if I draw two lines from this, look, if I draw two lines from this, if you watch this diagram carefully, if I consider one of this angle is I1 and other angle is I2, where I2 in this case is greater than I1, correct? Because we are moving from left to right. We are getting the same value of deviation. That means for two angle of incidence, prism produces same deviation. For two angle of incidence, prism always produces same deviation, except when delta is minimum. Okay. Now let me show this with the help of the diagram, so you can understand it better. Correct? Watch it. Let me take a prism first. Let me draw a prism. Now, let me draw the light rays. Okay. And this is the emergent one. Now watch. This is I1. Sorry. This is the incident ray. And this is angle of incidence, I1. And this is R1, this is R2. And this angle is what? Angle of emergence, correct? Now, look, if I extend this line in backward direction or forward direction, correct? Look, now this is the deviation. Now this is the deviation. That means when I1 is the angle of incidence, I2 is the angle of emergence, delta is the deviation. Now we know from the principle of reversibility of line, if we can arrange to retrace the path of the light ray, means if I put a mirror on its path so that it will incident on the mirror normally, it will goes back normally, correct, in the following this path. So in that case, what will happen? I2 will be the angle of incidence and I1 will be the angle of emergence. That means, look, either it is I1 or it is I2, delta is same. That means prism produces same deviation for two angle of incidence, and one of that angle is angle of incidence, another is the angle of emergence. But if you come closer, correct, and at this point, what is happening? Both of these 2 points are merging, correct? So this is the point for which prism produces minimum deviation. So remember this condition. When delta is equal to delta minimum, angle of incidence and angle of emergence are always equal to I. Correct? I can show this proof by doing some mathematical calculation also. Correct? So let me show this proof to you. Correct? Okay. So let me erase this. So I'm going to show that proof that in case of delta minimum, I'm going to show you that proof. That means if delta equal to delta minimum, I1 equal to I2. Okay. So proof for this is what happened when delta equal to delta minimum. Now we know delta is equal to I1 plus I2 minus A. Now for a given prism, as I said earlier, I1 plus A is constant. Now remember, delta is what? It is the difference between sum of I1 minus plus I2 minus A. Now A is constant. So delta will be minimum if and only if these possess the minimum value. Then only the difference is minimum. Correct now? So how to calculate the minimum value of I1 plus I2? Let me show you that. I1 plus I2. So can I write this I1 plus I2 in this way? Root over of I1 square plus root over of I2 square. If I write it in this way, we also can write this is A square plus B square. We can write I1 minus I2 whole square plus 2 root over of I1 I2. Correct? This is I1 plus I2. Now what happened? Look here. This is a square, correct? And what is the minimum value of a square? Square of a thing cannot be negative. Square is always greater than equal to 0. That means the minimum value of a square is always equal to 0. You can check it out, correct? Because minus 2 square is 4. It is not minus 4. So similarly, root over of I1 minus I2 whole square, these will be minimum when this square is minimum. So I1 plus I2 is minimum when root over of I1 minus root over of I2 whole square is equal to 0. It means root over of I1 minus root over of I2 is equal to 0. That means I1 equal to I2. Okay? So, look, this I showed you earlier also, correct? So this I shown you earlier also from the graph. Now I'm doing this by mathematical way, correct? So let me write down this. Let I1 plus I2, sorry, I1 equal to I2 equal to I1 equal to I2 is equal to I. Now, if I put this value, correct, this only can be written when delta equal to delta minimum. So what I am writing here, when delta equal to delta minimum, I1 equal to I2 equal to I. So we can write this formula, minimum deviation delta minimum is equal to I plus I minus A, which is equal to 2I minus A. Correct? Clear? So this is a very, very important formula. Please keep it in mind and try to practice it. Correct? Now, if I1 equal to I2, what is the relation between R1 and R2 there? Now, let me derive that relation also here. Correct? Now, watch it carefully. Let me erase this. So, I'm going to show this proof in a simple way. Okay. Let me draw a prism again, whose angle of prism is A, whose angle of prism is A, and this is B, and this is C. Now I'm going to consider the case of minimum deviation. Okay. So in case of minimum deviation, what we can write? So let me draw the diagram first. Now, it is quite clear from this lecture that I1, if deviation is minimum, this is also, if this is I, this also be equal to I, because angle of incidence equal to angle of emergence. Correct? Now let me write this as R1 and let me write this as R2. And assuming the material of the prism is mu. Now I'm going to apply Snell's law. Okay. So let me write it like this: P, Q, R, S. So I'm doing it for PQ and QR for this pair from one air to prism. Apply Snell's law. Sin I by sin I equal to, okay, you can apply that way also. It's a better way. Here I taught you Snell's law in general form. That is mu1 sin I equal to mu2 sin I. If you remember that, I told you this. This is very easy to apply. Okay. Mu1 means refractive index of first medium. It is considered to be air. So refractive index is 1. Sin of I. Mu2 in this case mu. So sin of R. So what we can write? We can simply write sin I by sin R1 equal to mu. Now I'm doing this for this pair QR and RS. Now light is moving from denser to rarer medium, and is from glass to air. So applying mu and angle of incidence sin of R2 is equal to, now in air mu1 is 1 and sin of I. If I do it, now look at this, what will happen? Mu is equal to sin of I by sin of R2 is equation 2. Now both of these are equal to mu. If I equate this, so what will I get? Sin I by sin of R1 equal to sin of I by sin of R2, which is simply equal to sin I get cancelled. That means R1 equal to R2. Yes. So in case of minimum deviation, I1 equal to I2 is equal to I. Similarly, R1 equal to R2 is equal to R. That means both of these are equal to R. So what will be the value of the angle of prism then? We know A equal to R1 plus R2. And A equal to R1 plus R2 means A equal to R plus R, that is 2R. So what we can write, A equal to 2R. Okay. So these are the formulas which are very, very important for minimum deviation. So in terms of I and R, I can able to write the formula in this way also. Delta A is equal to 2I minus 2R, or 2, let's take 2 common, I minus R. This is the very, very good technique, okay, and very important formula. You have to remember this. Okay. Now, I'm going to show you what will be the laws of reflection, that means refraction, that means how to write Snell's law in terms of minimum deviation and angle of prism. Okay. So now next topic is how to write Snell's law. How to write Snell's law. How to write Snell's law in terms of minimum deviation and angle of prism. How to write Snell's law in terms of minimum deviation and angle of prism. Okay. Now look, if we know that delta M equal to 2I minus K. So we can write it 2I equal to A plus delta M, where I is equal to A plus delta M by 2. Okay. And what we know, 2R equal to A, hence R equal to A by 2. Correct? Now I'm going to apply Snell's law. Correct? Now, for example, let me draw the prism again. Let me draw the prism again. These are the incident ray. Okay, this is I, this is R, this is R, and this is I2. Okay, and this is A. Clear? And suppose it is moving from medium 1 to medium 2. Refractive index of medium 2 is mu. Applying Snell's law in the general mode, that is applying this formula mu1 sin I equal to mu2 sin I. Now mu1 means this medium here 1 sin of I, mu2 that is mu sin of R. Therefore, if you watch it carefully, we can write mu equal to sin of I by sin of R. Okay, mu equal to sin of I by sin of R. Now, what I'm doing, just I'm going to put this value in this equation. So replacing I by this, so sin of A plus delta A divided by 2 divided by sin of, replacing this R, A by 2. So ultimate formula is mu equal to sin of A plus delta A divided by 2 divided by sin of A by 2. This is the representation of Snell's law in terms of angle of minimum deviation and angle of prism. Correct? So now the next topic is this. What will be the path of the light field? What will be the path of the light field? Through the prism in minimum deviation condition. Okay, for that you have to follow my next video. Okay, good night.